This is a video from section 4.9. The directions say to find little f. We're going to start with f double prime of t equals t squared minus 4. But to find little f, we have to find little f prime. And so f prime of t, so I need a function whose derivative is t squared minus 4. Well, a function whose derivative is t squared is t to the third, but remember we have to multiply t to the third by a third because we want the coefficient of t squared to be 1. And a function whose derivative is 4 is 4t. So we subtract 4t, but then don't forget we have to add c. Now that we have f prime, we can find little f. And so f of t. So again, I need a function whose derivative is 1/3 t to the third. Remember that the 1/3 goes along for the ride, and I'm going to add 1 to that exponent. Well, that's going to be t to the fourth. But I'm going to multiply t to the fourth by 1/4. And so, again, that's the function whose derivative is 1/3 t to the third. And then I'm going to subtract 4 times the function whose derivative is t. Well, that's 1/2 t to the second, because remember there's a hidden 1 on that exponent. And then the function whose derivative is a constant, you just write that constant times t. And then, but we need the general antiderivative, so we have to add another constant, but we'll call it d. And the reason why we're calling it d is because c is already taken. So f of t is 1/12 t to the fourth minus 2t squared plus ct plus d. And that's how you do the first example. Let's do another example. Suppose I did example 2. Suppose I had f double prime of x is 2x plus 3e to the x. So f prime of x. Now think of a function whose derivative is 2x. That's going to be x squared. The derivative of e to the x is e to the x, so we get 3e to the x plus some constant c. And then if I want f, think of a function whose derivative is x squared. That's going to be 1/3 x cubed. A function whose derivative is e to the x is e to the x, but remember that 3 goes along for the ride. And then a function whose derivative is c is cx, and then we just add d. And that's how you do example 2. Example 3. Suppose I had f prime of x equals square root of x minus 2. And then I'm going to impose an initial condition that says f of 9 equals 4. So there's a couple of comments I want to make. F of 9 equals 4 means when x is 9, I'll say f of 9 is 4, right? So this is a y value. So f of 9 represents a y value. That y value ends up being 4. Now, remember that f prime of x equals square root of x minus 2, which is the same as x to the 1/2 minus 2. So f of x is, now if I add 1 to the 1/2, I get 3/2. Okay, but then I'm going to divide by 3/2. And we'll fix that up in a minute. And then I subtract 2x, right? Because 2x is the function whose derivative is 2. And then I add c. And so f of x is 2/3 x to the 3/2 minus 2x plus c. But we have an initial condition. The initial condition says f of 9 gives me 4. That's going to allow us to solve for c. So f of 9 is 2/3 times 9 to the 3/2 minus 2 times 9 plus c. And by the way, that's equal to 4. Now, square root of 9 is equal to 3. 3 to the 3rd is 27. Okay, so this is 2/3 times 27 minus 18 plus c is 4. But 3 goes into 27 9 times. Let me get rid of that equals. And so 18 minus 18 plus c is 4. And so what that says is c equals 4. And we're done. So f of x is 2/3 x to the 3/2 minus 2x plus 4. And that right there was example 3. For example 4, suppose I had f prime of x is 5x to the 2/3, and f of 8 is the same as 21. And so f of x is 5 times. Now, if I add 1 to that exponent, I get x to the 5/3. But then I have to multiply by 1 over 5/3. Okay, same pattern. But if you guys can, and by the way, we add c. And so f of x, instead of writing 1 over 5/3, since we have a fraction, it's okay to write 3/5. And that's not an accident, right? So when you have a fractional exponent here, you take the reciprocal, and that's what you're multiplying x to that exponent by. So in other words, 3/5 is the reciprocal of 5/3. If you look back here, notice how 2/3 is the reciprocal of 3/2. It's not an accident. And in these situations, when I give you an initial condition, that's going to allow us to find a specific antiderivative. That's important. So f of x is 3x to the 5/3 plus c. So it says here, f of 8 is 21. Okay, so I'm going to plug in 8. So 3 times 8 to the 5/3 plus c is 21. So the cube root of 8 is 2, right? And so 2 to the 5th is 32. So 3 times 32 plus c is 21. So 96 plus c is 21. So C is negative 75. And so therefore, f of x is 3x to the 5/3 minus 75. Suppose I give you something like this. And by the way, that was example 4. So we're going to go to example 5. Suppose f double prime of x is 8x cubed plus 5. F of 1 is 0. And f prime of 1 is 8. So first things first, I need f prime of x. And so that's 8 times 1/4 x to the 4th plus 5x plus c, which is equal to 2x to the 4th plus 5x plus c. And so f prime of 1 is 2 times 1 to the 4th plus 5 times 1 plus c. But f prime of 1 is 8. So 8 equals 2 plus 5 plus c. So c is 1. Okay? So therefore, f prime of x is 2x to the 4th plus 5x plus 1. That allows me to get f of x. And remember, I'm adding 1 to that exponent, so it's 2 times 1/5 x to the 5th, right? And then add 1 to that exponent, right? There's a hidden 1 there. So it's 5 times 1/2 x squared plus x plus... Now, we already used c, so you don't want to use it again, so we're going to use d this time. It's a constant, right? And so this is 2/5 x to the 5th plus 5/2 x squared plus x plus d. But remember that f of, well, let's go back, f of 1 is 0. And so 2/5 times 1 to the 5th plus 5/2 times 1 squared plus 1 plus d is 0. And so 2/5 plus 5/2 plus 1 plus d is 0. So I would get an LCD of 10, right? I'm old school. And so 4 over 10 plus 25 over 10 plus 10 over 10 plus d is 0. And so d is 29, 39, so negative 39 over 10. And so therefore, after all that work, we can say f of x is, let's go back over here. So I'm going to get 2/5 x to the 5th plus 5/2 x squared plus x minus 39 over 10. And that's a specific f that satisfies those initial conditions. And let's do one more. we'll call this example 6. Suppose f, we'll throw in a trigonometric function, f double prime of theta is sine theta plus cosine theta. And I'm going to say f of 0 is 3, and f prime of 0 is 4. Now, if I want f prime of theta, think of a function whose derivative is cosine theta. Well, that's sine theta. And a function whose derivative is sine. Now, if I just put cosine, the problem is the derivative of cosine theta is negative sine theta. So to compensate for that, I have to multiply that cosine of theta by a negative. And then I'm going to add c. So f prime of 0 is equal to 4, in fact. Let's go back. So negative cosine of 0 plus sine of 0 plus c equals 4. Negative 1 plus c is 4, so c is 5. So therefore, f prime of theta is negative cosine theta plus sine theta plus 5. So one more time, we're going to take f of theta, and that's going to be negative sine theta minus cosine theta. Because remember that the derivative of cosine theta is negative sine theta, and when you have two negatives next to each other, you get a positive. And then we get 5 theta, that's the function whose derivative is 5, plus some constant d. But we have to go back. Remember, f of 0 is 3. So negative sine of 0 minus cosine of 0 plus 5 times 0 plus d is 3. And so negative 1, sine of 0 is 0, right? Plus d is 3, so d is 4. And then we're done. Because now I could say f of theta is negative sine theta minus cosine theta plus 5 theta plus 4. And that'll conclude this video for section 4.9, and this is on antiderivatives. Okay, thank you. And I believe we did 6 examples. Yep, 6 examples.